Hey guys, this is Carrie, and in this video we are reviewing Lesson 3. Alright, so we have done the do now together, we've done the lightning round. What we're going to be doing next is we're going to be putting each of the following in simplest radical form. Alright, this is a little scary because we got a bunch of variables underneath here. We kind of looked at this in one of the do now problems. So for this one, square root means we're breaking these guys up into their factors. So A, and I'll hold off on the B's for now. Alright, so with the A's, we have 6 of them total. We're trying to make groups of 2, so we have 3 sets of twins. Now, pause for a moment. We probably could have figured that out without actually writing the A's out. We're trying to make groups of 2, right? So 3 groups of 2 gives us our 6 total A's. Alright, so from each of these groups, one is going to escape, one is going to die, and that leaves us with A cubed outside. Now instead of writing the B's out, let's see, we would have 13 B's. How many twins can we make with 13 B's? It's kind of tricky because it's odd. But thinking about if we had twins, one twins is going to be just 2. 2 twins would be 4. I think 6 groups of twins. And that would leave us with 12 plus 1 extra. So from those 6 groups of twins, I think 6 are going to escape, 6 are going to die from those twins, right? Because each twin, 1 escapes, 1 dies. But then that 1 extra, he didn't have a twin to try to escape with, so he stays in jail. So it's kind of awesome to be able to do that without writing the B's out. Let's see, for the next one, there's just one new piece here. Square root of 40. Okay, well we have to break the 40 down. Two times 2 times 2 times 5. X to the 8th. Maybe we can actually handle these. Oh god, why do the 100 first? Oh man, we really don't want to do that. Maybe we can handle those in kind of a smart way. So here with our twins, 1 escapes, 1 dies. So we have a 2 out front. X to the 8th. How many twins, how many groups of 2 can we make there? I think that's 4 groups of 2. So 4 of those are going to escape, and the other 4 are going to die. Oh, I forgot about the Y's. This is the part I didn't want to deal with. But from 101 Y's, we can make, 50 twins. Because 50 times 2 is 100. And then 1 extra one inside jail. So from the 50 twins, 50 of those escape. Their twins all die. And then left inside of the jail is 2 times 5, 10, and 1 extra Y, which is Y. Alright, this next one you definitely don't want to do by actually writing it all out, so see if you can figure it out. Alright, the last new thing that I need to teach you today is something called a higher root. So these are also called nth roots. And if you want to type it in Desmos, once you're in that math type, you can type nth root, and it will automatically give you the shape with the little number here. Now what that little number means is it tells you that this is actually a harder jail to escape from. This is a cube root jail, and we're going to look at mathematical applications of this, but first we'll focus on simplifying it. This is a cube root jail, so instead of taking twins, we need triplets. We need groups of 3 to escape. So we try to break 8 down. 8 becomes 2 and 4. 4 becomes 2 and 2. So we get cubed root. The little 3 here is read as cubed root, or third root. And we're taking the third root of 8, so we have 2 times 2 times 2. And guess what? We have our triplets. So that's perfect. So you're going to try to escape as a group of 3 this time. But when they try to escape, none This time, it's a harder jail. The 3 means it's tougher. So still only 1 gets out. No matter what group size, only 1 ever gets out. But this time, the other 2 die. And so since the 1 got out, we're left with 2. And everyone else died. There's no one left in the cube root. So this is our final answer for this one. For this one here, we've got the 4th root of 6,250. Wow. Okay, so it's 4th root. So this time they're going to try to escape in groups of 4. Okay, we got to break this down the same way that we did before. 6,250 can be broken into 625 and 10. You can use your calculator to do some of those divisions. Probably 2 and 5 are the easiest to notice here. This is 5 and 125, 5 and 25, 5 and 5, 5 and 2. And you can just use your calculator for all of those. So here we go. We've got 5 times 5 times 5 times 5 times 5, 5 5s, and a 2. And they're trying to escape in groups of 4 this time because we have a 4th root jail, so it's a really strong jail. I see 1 group of 4. All but 1 die every single time. Only 1 can ever escape, no matter the group size. So the 5 gets out. And here I've made a mistake. I wrote this as a square root, but this is really a 4th root jail. So this is a 4th root of who's left in jail. 5 times 2 is 10. So we have 5 outside the jail, and then the 4th root of 10. It's not 5 to the 4th. It's not that. The 4th is with the jail, with the root. All right, you can skip problem 1C and continue on. For these variable ones, these work exactly the same way that you might expect. You're going to have to start off probably the slow way by breaking the 6 down. And finding those groups of 3. But for now, and I think you'll find a shortcut when you do that. But you have to do it the long way a couple times to find the shortcut. But for now, starting with problem 2, please continue on to the rest of these. You've got to do through problem 6 today. All right, good luck.